All right, guys, welcome back. Did anything pop out at you guys while you were going through the sort of last half of the test? Anything that looked tricky? Anything you didn't understand? Anything at all? If not, I'll just keep going and plug away with some of the questions that I think are a little bit more difficult. Nobody had anything that came up? Maybe 5 minutes wasn't enough? All right, I'll just keep going then. I guess 29 was maybe a bit tricky because, thanks Taylor, the questions, the lines weren't drawn as full lines across the graph. There was only just little segments. So the first thing I did was I grabbed my ruler and just continued the lines all the way across the little plots. And then I could see where they intersected. That was kind of the tricky bit there. 32, 33, and 36. Definitely. Infinite number of solutions. So now we're into solving systems of equations, looking for either, different slopes. If it's the same slope, does it have the same y-intercept? Is it the same line? This one is asking for an infinite number, so that means they're the same line. So we're looking for two lines that are that have the same equation. That one was A because it was just this guy down below is just 2 times the one up above to get from there to there. That was a pretty obvious one. 41, thanks Abby. Let's get on to Taylor's question here, 32. Perimeter of an isosceles triangle is 28 inches. The length of each equal sides is 1 inch less than 2/3 of the length of the third side, which the following systems represents this situation. So I guess this one's a little bit complex because you're trying to decipher what they're talking about in terms of the two equations. Let's see, what did I do here? So the perimeter of an isosceles triangle is 28 inches. That means we have a triangle that has 2 sides that are equal. I didn't think this was, I don't really get much say with these provincial exams, but it didn't seem super fair to me that they're asking about the definition of an isosceles triangle. That's not likely something you'd remember, but anyways, if we called this side x and this side y, we'd have 2 times the length of side x plus the length of side y is 28. So that gives us a bit of a hint as to which one. So I automatically see C here doesn't have anything like that, so I'm going to get rid of C. So now I'm just looking at the 3 other options. And then the second piece of information, the length of each of the equal sides is 1 inch less than 2/3 the length of the third side. That's a lot to take in. Let's see if we can break it down. As soon as I see the word is, that is an equal sign. 1 inch less, that's going to be -1. And then 2/3 the length of the 2 sides. So the length of each of the equal sides, so the length of x, those are the equal sides, is, and then 1 inch less, so I'm going to subtract 1, and then 2/3 of the other side. So if I put it in like that, do I have anything that kind of looks similar? 2/3 x minus 1. I'm liking this guy. Because this is y is the side that's kind of by itself, and then we had x, which we called the same sides. So that's a bit of a tricky one. At least we don't have to solve the system, we just had to set it up. So that was maybe a difficult one. 33, using different prime numbers, the prime factorization of x, y is, so the least common multiple is taking the largest power of each prime. So what this is saying is these are the prime factorizations. So if I took a factor tree of x, I would end up with a, I would end up with b cubed, and I would end up with c squared. And same thing for y. If I did a factor tree, I would break it down, and eventually I'd end up at a squared, b squared, and c. So when I find the least common multiple, I'm taking the greatest exponent of each of my powers. So here I have a squared, I'm going to take that, that's the biggest of the a's. Then I have b cubed, and then c squared. So that turns out to be answer C. A squared, b cubed, and c squared. That was kind of back to the definition of our least common multiple that we talked about. And there's two ways to find the LCM. This way forces you to remember that piece of information. So it's a bit of a, maybe a bit more of a difficult type one. 32, 33, 36, and then 41. And then maybe we'll call it a day there. So 33, 34, 35, 36. Which of the following is equivalent? Okay, when I'm multiplying my exponents with the same base, I need to add my exponents. So this is getting to our exponent laws. So if I'm going to add 2 over 5 and 3 over 2, I need to have a common denominator. So in this case, it's looking like it's going to be 10. So I'm going to multiply by 2 over 2 here, and I'm going to multiply by 5 over 5 here. So 2 times 2 is 4 over 10 plus 15 over 10. Add those together, I get 19 over 10. And then I just really need to remember that this is all x to the power of 19 over 10. And then I get back to my flowers of power, roots the root. If you recall that, I have my little flower up at the top here, growing. Then I have my ground and then the roots on the bottom. Because all of my answers aren't in nice exponent form like this. So I need to rearrange it into radical form. So the power was 19, that stays up here, and the root was 10. And that was D. So again, they're testing two exponent laws at one time. They're testing, do you know when you multiply, you add your exponents, same base, add your exponents, and then they're testing, can you convert a fractional exponent, a rational exponent, into a root? So that's the second piece there. Abby asked about number 41, so we'll jump down there. 39, 40, 41. Determine the factors of the area model. So we're looking at algebra tile type question. Remember, each one of these is a length, and each one of these is a length. And then on the provincial, it'll be in color, so it'll be a little bit easier. These would likely be red. So what length is this side? Well, that's length x, and that's length x. And they're all not shaded, so they're all going to be positive x. And then I have a bunch of ones here, so I have 1, 2, 3, 4, 5. So there's 5 there together, but they're red, so it's negative 5. So in total, I have 3 x's, and I have minus 5. And then here I have an x, and then I have 1, 2, and 3. So that's going to be 2x plus 3. So if I were needing to factor that, here are my factors. 2x plus 3, and then I have 3x minus 5. And I see these are both plus 5, and then I have 2x plus 3 here. So that's A for 41. So hopefully that helps you out. And you can see the type of question you're going to usually end up with dealing with algebra tiles. I didn't spend a ton of time on them because generally speaking, you're going to end up with a question like this. Nothing more difficult than that. So just can you understand what each of those tiles represents? If it asks for the area, or if it asks you to expand, you have x squareds, x squareds, x squareds. And then you have, x1, x. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 x's in total. And then you have negative x's here. So 1, 2, 3, 4, 5. So you have negative 10x. And then all of these ones down here. 1, 2, 3 by 1, 2, 3, 4, 5. So you have minus 15. So if I took that and multiplied it, I would end up with 6x squared. I'd have plus 9x minus 10x, and then minus 15. So just taking it a step further, that's another question they could ask with a similar type setup. I'm going to just leave there for today. You guys have been working really hard. You had your test yesterday, and I know you probably didn't want to come to class and do a ton of work, but you guys do have your provincial next Wednesday, and I mean, it's up to you to kind of review and get as much done as you can in terms of review. So if you're still intending to get caught up, it'd be great to have everything done by Thursday, Friday afternoon at the latest. And I would love it if you guys continue to work through this exam and come back tomorrow with a few more questions. I don't have a lot planned for the next few classes. I guess we have 2 more. So I'm just going to continue working through this. We're at 40, so we have about 20 questions left. Probably get it done tomorrow. I'd love it if you guys had questions just in general. You know, Mr. Borden, I'm just not understanding exponents, exponent laws, or, you know, radicals, anything like that. Come with those questions the next couple days and we'll go from there. So Mrs. Ward will be in the studio at 10:30. So you need to jump over to her Blackboard. You can maybe even keep the live feed up or it'll switch. Sorry, you'll have to close it. But come back at 10:30 so you get a bit of a break and I will see you guys tomorrow. So have a good afternoon. Thank you.